Okay, let's take a look at this high fructose corn syrup consumption problem. It says a consumer group claims that the mean annual consumption of high fructose corn syrup by a person in the United States is 48.8 pounds. A random sample of 120 people in the United States has a mean annual high fructose corn syrup consumption of 49.5 pounds. Assume the population standard deviation is 3.6 pounds. At alpha equal 0.05, can you reject the claim? Okay, so first we want to identify the claim in terms of the parameter and write it as a mathematical statement. Okay, so my first step is to write this as mu equal to 48.8. Okay, so this is the claim. Okay, because the consumer group claims that the mean annual consumption by a person is 48.8 pounds. Okay, so because this contains the case of equality, this is going to be the null. So this necessarily makes the alternative mu not equal to 48.8. So this is going to be a two-tailed test. Okay. So let's go ahead and find the standardized test statistic. Okay, so I'm given from our sample that n is equal to 120, x bar is equal to 49.5, and we're assuming that the population standard deviation is 3.6. Okay, so putting that into the test statistic formula, we get 49.5 minus 48.8 over 3.6 over the square root of 120. Okay, so we're concerned with whether or not this difference between what we observe and what we claim is statistically significant. Okay, so putting this into the calculator real quick. See here, 3.6 divided by the square root of 120. Okay, I get a test statistic of about 2.13. Okay, so the next thing I need to find is the critical value. Actually, there's going to be two in this case because we have a two-tailed test. Okay, so my next step is to find the critical values. Okay, so the level of significance in this problem is 0.05. Okay, so I'm going to have two critical values because this is a two-tailed test. So I'm going to sketch the distribution. Okay, I asked for that in your lab. And shade two areas of rejection. And because I have two areas of rejection, I need to divide alpha by 2. So each tail is going to have 0.025 amount of area. Okay, so I'll have a positive critical value and a negative critical value. And they'll have the same absolute value because of symmetry. So we really only need to find one, and then remember that the other one will be the opposite. So you can use your standard normal table, read in the body of the table to get 0.025 and read outward to find that z-score. Or you could go ahead and use your inverse normal function. So I'm going to go ahead and do that. So I'm going to go inverse, oops, can't spell, inverse norm, and a cumulative area of 0.025 to get that lower one. Similarly, you could go ahead and find the upper one of using a cumulative area of 0.975. Okay, so putting that into the calculator, going to my distribution menu, My cumulative area for that lower critical value is 0.025, and I'm on standard normal, so I don't need to change mu and sigma. Okay, so I get negative 1.96. So my critical values will be negative 1.96 and positive 1.96. Okay, so I have two of these critical values here. Okay, so at this point in time, I can take a look at my test statistic and see that I am clearly in this rejection region, okay, because I'm above 1.96 on the horizontal axis. Okay, so I know that I'm going to be rejecting the null. Okay, let's go ahead and find the p-value. Okay, remember, it's the probability of getting a test statistic at least as extreme as the one obtained by the sample. Okay, so what we want to do is we want to find the probability associated with our test statistic, okay, in terms of being more extreme. So my test statistic is way out here in this tail. Okay, so Z star is way out here. So I want to find this little bitty area. Okay, I know this little bitty area is going to be less than 0.025 and certainly less than 0.05. And remember, the decision is to reject the null when your p-value is less than or equal to your level of significance. But to find the p-value by hand, there is a catch with a two-tailed test. Okay, so because we're comparing this amount of area to half of alpha, we really need to double this p-value, okay, to correctly compare it to our level of significance. So it's going to be 2 times the probability we get a z-score greater than 2.13. Okay, so at this step here, I could use my normal CDF, my normal cumulative density function. Okay, so going to the calculator, I'm going to press distribution. Whoops, sorry, it's a shift key. Okay, distribution, I want normal CDF. My lower bound in this case is 2.13. My upper bound is a really large number. Okay, theoretically it's positive infinity. I'm not going to touch mu or sigma because I'm on the standard normal curve. Okay, so I get an area of 0.01659. Okay, so this is going to be 2 times 0.01659. Okay, so I have to double this amount to get the correct p-value. Okay, so I'm just going to multiply that by 2. Okay, so my p-value is approximately 0.03317. Okay, so let's compare the p-value to alpha. Okay, so my p-value is 0.03317, and my level of significance is 0.05. Because the p-value is less than or equal to 0.05, I'm going to reject the null. Okay, and we can clearly see that when we look up here on our curve. Okay, our test statistic is well in the rejection region, and the area that corresponds to the test statistic is well below our level of significance. Okay, so let's go ahead and write the conclusion. Okay, so the conclusion is going to be that we're going to reject the null, but it isn't enough to say reject the null. Okay, we want to write the conclusion in terms of the claim, whether or not we're supporting the claim. Okay, so I'm rejecting the null. So I'm going to go back and take a look at the claim. Okay, so I'm rejecting the null, therefore I'm in favor of the alternative. Okay, that means that there is not sufficient evidence to support the claim. Okay, so reject the null. There is not enough evidence to support the claim. Whoops, sorry. That the mean annual consumption of high fructose corn syrup is 48.8 pounds. Okay, so we can take a look at the confidence interval and see what that's telling us. Okay, so we're clearly deciding that we are ruling in favor of the alternative and the claim is not supported. Okay, so we're in favor of saying that the mean is not 48.8. So what does that mean? Does it mean that the true mean is more than 48.8 or is it less than 48.8? So the confidence interval will help us look at that. Okay, so since my level of significance is 0.05, I want to find a 95% confidence interval for mu. Okay, so I'm going to go ahead and use my calculator for that. Okay, so again, I'm going to go to Stat, then Tests, and then, Stat, then Tests, and go to Z interval. And again, either I have the raw data or the summary statistics, which is what I have in this case. Okay, so I'm going to select Stats and then put in the information given. My standard deviation was 3.6. My sample mean was 49.5. My sample size was 120, and my level of confidence is 0.95. Okay, and then I'm going to press calculate. Okay, so my confidence interval goes from about 48.9 up to 50.1. Okay, so let's compare that to our hypotheses here. Okay, I'll stick it right below. Okay, so we are rejecting the null and we're in favor of the alternative. This confidence interval is supporting that. In fact, the confidence interval shows us that the true mean is probably more than 48.8. Okay. All right, last but not least, let's go over how to get our test statistic and p-value on the calculator. Okay, so to do that, I'm going to press Stat, right arrow over to Tests, and I want to select the ZTest. Okay, so I want to change my null parameter to 48.8. It kept the standard deviation from the confidence interval as well as X bar and the sample size. But now I want to change the direction of my alternative. I had greater than left over from some other problem, so I want to select not equal to and then calculate. Okay, so looking at our test statistic and p-value, that's pretty much the same thing we got when we calculated this by hand. What's nice about the calculator and also in StatCrunch is that if you indicate that it's a two-tailed test, it will appropriately double the p-value. Okay, and last but not least, since we have rejected the null, it is possible that a type 1 error may have occurred. Okay, so I asked for that on your lab. A type 1 error may have occurred. Sorry about that. Since the null was rejected. Remember what a type 1 error is. It's the probability of rejecting the null when the null is really true. Now, we're not saying that a type 1 error was absolutely committed. It means that since we're basing our decision on a sample, it's possible just by chance, not on purpose, that we came to the wrong conclusion. So since we rejected the null, a type 1 error may have occurred. Okay, so if we had failed to reject the null, then a type 2 error may have occurred. What's important to remember is that you cannot have committed a type 1 and type 2 error at the same time, because it's not possible to reject and fail to reject the null at the same time.